Hey folks, welcome to the course, and the first thing I want to do is to create a plastic toy material. And before that, let me just make sure that we are on the same page. In the starting parts of this course, I am actually using the version 1.0.14.0 of Arnold for Cinema 4D. This version at the time being is still at the beta, and I think in a few days it will be public. And the reason actually I'm not starting with a public release and I'm using a beta release is the fact that this version 1.0.14.0 has a very important shader, which is curvature shader, and it's extremely essential for me while developing materials. So I really can't go back to 1.13 at the time being, 1.0.13 at the time being. So I'm going to be using 1.0.14, and by the time this course is released, definitely you're going to have 1.0.14 at your hands too. It still actually have some bugs in this release, especially if material previews are sometimes just not get updated as they should be. But as I said, because it has curvature shader, it is impossible for me to go back personally. So we're going to be starting the course with that. Now, in this lesson, we're going to be creating a very simple plastic toy material. And the way I'm going to be going about this course is I'm going to start with laying down simpler concepts, and as we progress through the course we will be talking about more complex concepts and adding more layers of realism to our material. And I think this is a better approach, because if I lay down so many things in this lesson, it would be a bit hard to digest. And let's see how we can go about that. And this is the scene I'm going to start with, and this is a very basic example. I have a very simple camera, obviously, and as you can see, we have this huge stage just as a backdrop, and I have three lights in the scene. I have this, if I get back to my camera, the first light we have in the scene is this Arnold sky, obviously. So if I just run my IPR here and just turn off other lights, here's our Arnold skylight. You can see this provides the main lighting and our main reflections. And when actually working with materials and developing shaders, I believe the best way to go about developing them would be to kind of do that in a realistic environment. And basically an Arnold sky with an HDRI as the color input would be the best thing to do. The second light that I have, and it basically works as my second main light, is going to be this orange light that we have, as you can see, in this part of our scene. And it has some basic controls, an intensity of 1.5, exposure of 4, and to have a cleaner renders, I have increased the samples for this to about 3. And as you can see, it has this warm orangish color into it. And we have a blue light on the right side, which is going to be this one. And if I turn off my orange light, you can see how it affects the scene. And this is what we have as our kind of a backlight to fill some shadows and add some dramatic lighting effect. And if you select the blue light, you can see it has an intensity and exposure of 2, the same 3 as samples, and a bluer tone to it. And finally, I have another color, which is going to be this overhead type of softbox to provide some nice lighting for the edges. So that's our very basic lighting for this scene. And let's get back and start our creation process. If you take a look at this picture, this is a picture of a bowling ball, a very simple bowling ball, right? But it is a very nice example of how reflections and actually work. And in this lesson, we obviously are not going to go ahead and create everything in this picture. We're going to start with some basic, more common concepts and start and develop more complex concepts as we go through this. I want you to take a look at this picture. Forget the fact that it is a bowling ball, forget its color, forget the unevenness of the reflections and the specular highlights, and the fact that there are some blurry parts, some sharper parts. Just purely look at the reflection, right? I see two things. The first thing is obviously the Fresnel effect. These parts, these frontal angles, these faces that are looking basically parallel to our viewing direction are less reflective compared to the edges, compared to these faces that are looking perpendicular to our viewing direction. You can see these guys are less reflective, and as we go through to the edges, look at these parts, they are actually more reflective. Look at this very edge, how reflective. It's basically, it's like 100% of reflection at this edge. And another thing that's actually happening is the fact that not only the reflections and the speculars are getting stronger as we go through the edges and as the faces are becoming more perpendicular to our viewing direction, another thing is actually happening, and it is the fact that reflections are also getting sharper. So these reflections at these frontal angles are quite matte, but as we go through and take a look at these edges, take a look at this edge, how sharper the reflection is compared to this matte reflection at this frontal angle. Or take a look at this edge, take a look just closely how sharp the reflections are. So basically two things happening, and this is a kind of universal rule. First of all, the reflections are getting stronger as you go toward the edges, or as the faces are actually becoming more perpendicular to our viewing direction, and also they become sharper. So these are two basically concepts that you need to be familiar with, and we try to implement some of this concept as we go through. Now, as we are trying to create some basic plastic materials, and we're starting with a simple toy plastic material, let's actually take a look at this plastic toy here. And there are obviously different types of plastic here, some more matte, some more reflective, different colors, but let's take a look at this red part. And there are a few things obviously you see in a plastic material. It's quite reflective. We obviously see the Fresnel effect quite obviously, and we also have these two levels of distortion that's happening on the surface. The first one, if you take a look at this softbox here, you can see we have this kind of wavy effect, and another level of distortion are these very smaller distorted edges that shows us that the surface has two levels of distortion, this large distorted effects and this very smaller distortion that's happening. So let's go ahead and try to recreate something like this. Okay, let's start with creating a very simple Arnold standard shader here, and let's name it plastic sharp, and open it up. I'm going to middle click on this so we directly open the network editor, and actually I'm going to stop my IPR and right click on this preview and change this preview to actually be the Arnold shader ball sphere. And let's start this. So if you select your standard shader, obviously the first thing is to select your diffuse color, and you can go ahead to, it's a plastic, so you can choose whatever color you want. In this case, I'm going to use this greenish color. You can see 68, 159, and 46 for RG and B values, and press OK. And I'm going to increase my weight value to something like 0.85. Then let's go ahead to our specular section. And I'm going to go and use something 0.5 for the overall specular reflections and the weight of our specular. And obviously reduce the roughness to something like 0.1 in this case. The first thing you need to do when you are trying to create a reflective material is to turn on Fresnel. Right? So now we're getting that effect that the frontal faces are less reflective compared to the edges if you take a look at this preview here. And the way to control the Fresnel is going to be using your refraction section. You have this Fresnel use IOR. If you now basically tick this, you can go ahead and control your Fresnel using this IOR value. And you can go ahead and find out about the IOR values for different materials and for different for plastic, metal, for whatever, easily on the internet. And you got this website called refractiveindex.info, and you can search for different materials and find out their exact IOR or index of refraction value. And for plastic, it can be something like 1.45, 1.5, 1.6, and in this case let's go to something like 0.55, 1.58 maybe. And as you can see, our frontal angle are becoming more reflective this time. Great. So this is your basic plastic material, and one thing that I want to say right now here is there is one basic rule that says the overall weight and diffuse weight and specular weight shouldn't be more than 1, and right now, as you can see, is 1.35. We have a weight of 0.5 for our specular weight and a weight of 0.85 for our diffuse weight. And this is true, but not when you're actually using Fresnel. But because when you're actually using Fresnel, you're basically using a less amount of specular weight at the frontal angle. So you are allowed to bend this rule a bit and increase the sum of the diffuse weight and specular weight to be more than 1. So that's why we are not actually taking that rule into consideration in this case. Now the next thing actually I want to add is going to be adding that bumpiness that we had in this picture. And to add that level of distortion, basically I'm going to be using a noise map, a noise shader to be used as the first distortion, and using another image, a black and white image, to kind of recreate this second smaller distortions. So let's go ahead and do that. The first thing, obviously, I'm going to be adding the bump here, and let's use a noise, and also let me load an image node at the same time, right? Also, let's close this and apply this material to our plane here and run the IPR. So this is our basic plastic material, which is not that great, but we're gonna making it a bit more realistic in this lesson. So we have this noise shader. Let me just press Ctrl-Shift-V to actually see it in the IPR. It's now connected to the Arnold Beauty. Obviously, to get that first level of distortion, let me just increase the scale of my noise. Maybe 4 or maybe 5 here. Let's add distortion a bit. Maybe start with 1 and see. I think it's just way too distorted. Go 0.6. That's better. 0.5. Okay. And now we have the first level, and if I just go ahead, go to the image node, and if you go to your text folder, you get this black and white images, and I'm going to use this BW4 image here, and let's Ctrl-Shift-V to see it in the viewport and in the IPR, sorry. And as you can see, I just want to be a bit smaller because I want that fine level of bump happening because of this image. So let's increase the scale maybe to 2, or let's go to something like 3. That's a bit better. Now I want to basically mix this two map to get that final bump effect. And to do that, you can use a mix node or a layer color node. Honestly, I use a layer color node a lot, even for these very simple combinations, because it's just more versatile compared to a mix map, but the mix map is smaller and it's easier to work with. So let's go ahead and start with a mix map. Mix map basically has 2 inputs and a mix amount. So right now, if I connect this mix map directly, you can see we are just getting black. But if let's use this red color as my first input and this blue color as my second input. So now we get a combination 0.5 of red and 0.5 of this blue color, which gives us this purplish final color. And we have this mix amount. At this time it's 0.5, so we get 50% of each. And if I go ahead to something like 0.4, anything less than 0.5 is gonna favor the first input, and anything more than 0.5 is going to favor the second input. So if I go to something like 0.1, you can see we are having more of the red. If I go 0.01, we are only having red basically. And if I go to something like 0.8, we are having more of the blue, right? And also you can control this mix amount using another map, for example, like a noise map. If you wanted to, just, for example, I can say this is the mix amount. And you can see now those two colors are basically mixed together based on the black and white information of the noise map here. So that's how the mix map works. In this case, we want to mix this two map, the noise and the image node. So let's connect the noise to the first input and connect the image to the second input. Right? Now we get 50% of the noise and 50% of the image. Sorry, it's set to it's just set to 0.5. You can see now we get 50% of the noise and 50% of the image. And I think I want to have more of that image affecting the noise. So let's go to something like 0.6 maybe, 0.7. And now for the bump map, I can use this mix as the bump map and use our main standard shader as our shader. And let's just connect the bump map to the Arnold Beauty port using Control-Shift-V after selecting it. And if I just hold down Shift and drag a region here, you can see the bump map is just way too high. So I'm going to select my bump map and decrease the bump height, let's say 2.2 maybe, and see what we get. Obviously this should run much faster for you. I'm running a few heavy software in the background and it should be a lot faster. So you can see 0.2 is still way too high. So let's go to 0.05 maybe. And as you can see, we start to get that nice, beautiful, small distortions, but it's still way too high, and it should be much subtler. So let's go to 0.01 and see if we get that nice small distortions here. Okay, I think that's nice. So this is basically your very basic, the most basic plastic material that you can create, and it can be somehow nice, but definitely it's not the most realistic one. So let me just go ahead and actually render this and just save it. If I go to my render setting and go to the output, let's use something like 1000 and 1000, and my Arnold render settings, you can see we have some sampling. I haven't changed the sampling, but in the ray depth I have my diffuse ray depth set to 2 and my glossy ray depth set to 3 at the time being. So I'm gonna just go ahead and render this, and when the render is finished, we're gonna come back and create some different plastic materials based on this material that we just created. Okay folks, so this is our first render, and as you can see we get those nice distortions. Maybe we can go ahead and decrease the mix amount, because right now I think the image is just affecting the bump way too high. But as you can see, we get this nice bump map all over the plastic. We got our nice Fresnel effects. You can see this part, for example, is less reflective if you compare it to the edge here, and this can be your very basic plastic material, right? If you wanted to create a rougher or blurrier version of this material, it's going to be very simple. If I just control drag this material, and let's name this plastic, let's just see. So that's going to be plastic rough. So if I open this up and make sure it's applied to my object, what I can do is simply select my standard shader and increase the roughness. So if I go ahead and increase the roughness to something like 0.3 here, hopefully the preview will show us. Sometimes the previews are just not working fine in this beta. So let me just go ahead and maybe render this section again. And as you can see, the reflections obviously are going to be the specular reflections are going to be way blurry and way rough compared to the previous render that we have. Okay, I can go ahead and actually render this thing too. So let's just go ahead and render this, and when the render is finished, I'll be back with you. So that's our second render, and as you can see, now we get this blurry reflection, and the render time is kind of at the same thing, so that's cool. Another thing that you see in some of the plastic materials and toys is the subsurface scattering effect. So if I just apply this first plastic shader to this material here and open up the shader itself, I can add that subsurface scattering effect very simply using the subsurface scattering shader as a section of the Arnold standard shader. So if I just come down here, obviously this is a very hard object here because we have very thin parts and very bulky, huge parts here. So I can try to use this color, maybe a brighter version of this, and increase the weight to something like maybe 0.6, and you start to get that subsurface scattering effect in this in these thinner parts. I can increase the radius obviously to get that subsurface scattering effect in these bulkier parts, but it wouldn't be that realistic. So I can just maybe just reduce the overall amount of radius to get a bit more realistic effect, and you can see you start to get that effect here. If I just render this section, you start to get that beautiful subsurface scattering effect in your plastic material, and it can actually make it more realistic. But in this case, this object isn't a good example and a good object to use with subsurface scattering because it wouldn't be visible in all of the parts unless you increase the radius like crazy. And if you increase the radius very much, now the effect would be quite different than a toy with subsurface scattering attribute to it. So as you can see now, we get this beautiful subsurface scattering effect in our plastic. So I'm gonna just go ahead and actually reset this values to default, so we are back to where we were. Now, one thing that I would like you to notice, if you take a look at this simple toy here, and if I zoom in, take a look at the specular reflections. We not only have this sharp specular reflection, we also have another basically layer of more spreaded reflection, which is, as you can see, it has a higher roughness. If you take a look at these parts surrounding our main specular lobe, you can see not only we have this very sharp one, we have another rough, more spreaded specular reflection basically. Now, in order to create something like that, unfortunately, at the time being, the GGX distribution model that we have in the basically standard shader can be the closest thing to this one. So if I come here and actually change my specular distribution for both of these guys to GGX, we possibly are going to have a bit more realistic results compared to the render that we had. So if we just try to maybe render these parts here, you get some of that tail effect basically, which can be very nice compared to the Beckman. Actually, in the update that I had for the Arnold, for the comprehensive introduction to Arnold for Cinema 4D, at the update I mentioned that the Beckman in some cases might be better than GGX, but after going through and creating tons of material with the Arnold, I realized that actually GGX is a lot more realistic compared to the Beckman, and I actually forgot to change the distribution model, the microfacet distribution model, to GGX at the beginning of the material creation, and that's something I will be doing, and I hope I wouldn't forget. So change your microfacet distribution to GGX because it's just simply more realistic. So what I'm going to do, I'm going to go ahead and basically take two renders, one with this plastic sharp and one with this plastic rough material, and this time with GGX, and we can simply compare them. And after we compare them, we go ahead and start to create that multi-lobe specular distribution that I showed you in the toy a few moments ago. So let me go ahead and actually take those two renders, and when those two renders are finished, I'll be back to talk about them. Okay folks, so the render is finished, and now I can compare the Beckman versions and the GGX version. This is our sharp plastic, and this is using Beckman, and this is using GGX. And maybe the difference is very small, but if you can take a look at these very edges, at these parts, in the GGX version, you can see we have more tail. We have the highlights are basically more broad compared to the Beckman version. The Beckman version is cutting the specular highlights in these points, see? But in here, you get this more of basically gradation between the two very high specular reflections and smaller amount of reflections that we have. But in the Beckman, as you can see, the cut happening very rough at this point. And in the rough version, you can see that the difference is kind of maybe a bit smaller, but in the Beckman version, you can see we still get that nicer tail in the GGX version compared to the Beckman version. So that's why actually I tend to use the GGX version for all of the material that I create in Arnold for Cinema 4D. So now we were discussing this kind of multi-level specular highlights, and the way to do that is going to be using some blending between these two basic plastic material that we have. So if I just duplicate this rough plastic material that I have here, and let's just name it plastic, maybe layered or whatever. So layered. Let's open the network for this. We have our first standard shader, which is right now having a roughness of 0.3, and also let's just make sure this is the shader applied to our plane object. So this is our first standard shader with specular roughness set to 0.3. And let me just show you that example here. One moment, just finding the picture. There we go. So for creating this effect, we obviously need two different plastic layers. I mean, if we had that multi-level specular layers, for example, in VR4 Cinema 4D, we have 5 specular layers, and creating this would be much simpler. But here in Arnold for Cinema 4D, we, at the time being, we can use some external, shaders, which I do not like to use it in a course like this, and I want to be as formal as possible. But there are some shaders like AL shaders, the AL standard shader, which actually allows you to have 2 specular layers per material. But in the Arnold standard shader, we don't have that, and we need to combine those two. So in order to create this multi-level, multi-load speculars, the sharp one and the more broader one, the rougher one, we need to use 2 standard shaders, one with tighter specular reflection and one with rougher specular reflections. So let's go ahead and actually do that. This is our first standard with roughness set to 0.3. I'm going to control drag the standard shader and set the roughness to something like 0.0, maybe 5 here, right? And right now, there we go. We have, if I just run my IPR, you can see we have this rough version, and we have this, and we have this sharper and glossier version. Now we need to combine those. And the way to combine those two things, those two basically standard shaders, is going to be using a layer color node and bunch of utility nodes. So let me just lay down a layer color node. And before actually connecting these standard shaders to this layer color node, I'm just going to show you how I'm gonna do it. And also I'm gonna show you this bowling ball picture that we had before. And the fact is that this sharper layer, this sharper standard reflection, should only appear, just let me here. Sorry. So that's the image. Okay. That's the bowling ball picture here. There you go. So the sharper reflections, basically, as I mentioned in this image, are more dominant in the edges, and they are less effective in this frontal angle. So we want to do exactly this in this picture. For example, if I just zoom in a bit, you can see the way we want to create this material is we want the sharper, the layer with sharper reflections to be more effective on the edges and to combine like 40–50% and these frontal angles. And the way we're going to be basically combine those two shaders is going to be using a layer color node, and as I mentioned, a bunch of utility nodes. So we have created the layer color node, and let me just show you what I want to do before kind of connecting the standard shader. So we have our layer color node, and I'm going to use it as my beauty port and run the IPR. So right now it's pure black. Let's say use again maybe a blue color, and again a red color, and press OK. If I increase the layer 1, we only get the blue color. If I start to increase my second layer, we start to combine our second red layer, right? Now the first layer is going to be the layer with rough specular reflection, and the second layer is going to be the layer with a sharper specular reflections. And obviously the way we want this to work is we want our second layer to appear more on the edges and combine with the first layer in these frontal angles. And the only thing we can do right now is we can use a facing ratio node, which gives us a Fresnel effect basically, or we can have more control using a utility node and adding a bunch of other nodes. So let me show you what I'm going to be doing here. First, I'm going to be using a utility node, and let's drag it here. Utility node, when the shade mode is set to n.I, if I just come here and actually connect this utility node, you can see it will give us a value between 0 to 1 based on the incidence angle. So right now, as you can see, the perpendicular faces to our viewing direction are getting 0, and these frontal angles are getting 1. And we want to use this utility shader and the nodes that are going to be connected to as the layer 2 alpha. And the way alpha works, obviously, when it is white, the layer 2 is going to show up, and when it is black, the layer 1 is going to show up. And right now, because we want our layer 2, which is going to be the sharper standard shader, to appear only on the edges, we need to invert this utility node. So in order to do that, I'm going to be using a complement node. So that's the complement node, and I'm just going to hold down Alt and release my mouse on the utility node and say insert after and use it as the input. Now we have basically connected the output of the utility node to the input of the complement node. And if you take a look at the IPR, you can see we are basically inverted our utility node right now. The frontal angle are getting 0, and as we get closer to the edges, we are getting 1. And if I just come here and directly use this as the layer 2 alpha and control my layer color to the Arnold Beauty, you can see we have this effect. We have our first layer showing up, which is going to be the rougher layer in the frontal angle, and as we go toward the edges, we get more of our layer 2. But right now we don't have anything of our layer 2 in these frontal angles. And the way to control basically these utility node and to have more control of the way that these black and white colors are applied is going to be using a ramp float node. So I'm just going to lay down a ramp float node. So select it, drag it, hold down Alt and release your mouse on the complement node and say insert after and use it as the input. Now the complement node, the output of the complement node is connected to the input of the ramp float node, right? So if I just connect the ramp float node directly to the Arnold Beauty port, you can see the effect. Right now we have the white part on the edges, and this is representing this point, representing those white colors. You see, if I zero it out, you can see we only have black, and we have the black parts that this point is representing them right now. You see there from 0 to 1. Now let me just show in separate windows so we can kind of see a better version of this. So if I increase the y value of this point, let's say to 0.4, you can see we start to see that white values more on the frontal angles. And if I just increase it completely, go to 1, you can see we only see white. But if I just, let's say 0.4, maybe something like that, 0.45, now we have a combination of our black and white color in these frontal angles. And if I just come here, because we want the white parts to be only on the edges, we can just go ahead and start. You can see maybe we can add, select this point, go to something maybe like this. Just playing around with the curve until we get that effect that we want. Maybe just to not get a perfect white, we can just reduce this value, maybe to something like 0.95. So now we are getting very close. If I come here and use this as the layer 2 alpha, which is, and connect my layer color node to the Arnold Beauty port, you can see we are getting very close. Now we having in this frontal angle, we are getting our layer 1, which is going to be our rougher standard shader, and we are getting our layer 2 more on the edges, but still about 50% of it in these frontal angles too. So now let's, instead of this colors, use our standard shaders. So this is our rougher standard shader. Let's connect it to the first layer color input, and this is our second, and let's connect it to our second layer color. And if you just take a look at these highlights here, what you can see is what we are basically trying to create, which is very beautiful. Now we don't have the bump right now. We haven't connected the layer color node as the shader yet, but just wait a second for the IPR to clean up. You can see not only we have these sharp reflections, which is coming from our second layer, we also have these more rough and more spread specular reflections, and we get this beautiful multi-lobe reflection, which if I just create a snapshot here and compare it to, for example, this plastic GGX here, which we had without the bump, you can see now we get that beautiful multi-lobe. We have this spread out specular reflection, which is rougher, and we have this nice, beautiful, sharp reflections. And as we go toward the edges, the basically the sharper specular reflections are becoming more dominant, and at this 90 degrees angle we basically don't have any rough specular reflections. Now let's go ahead and complete this shader by connecting the layer output to the bump map, to the shader, sorry, here. And we have our bump map, and let's connect the bump map to the Arnold Beauty and just wait for the IPR to finish. So there we go. I think we have a beautiful, sort of realistic plastic material, and we still can do a lot to make this plastic more realistic. We can introduce some color variation to the diffuse color. We can introduce some unevenness to the specular weight and specular roughness in different layers. And I just don't want to go that crazy in this lesson. We still have a lot to talk about, and we still have 2 or 3 other plastic materials to create, and in those examples we go all the way. But right now I think it's a beautiful example of how we can actually combine those specular layers. So that's it. Let me go ahead and actually final render. So as you can see, the render is finished, and we get this beautiful nice highlights, which is much more realistic compared to, for example, just this or just this, right? This one has more character to it, and the way the materials work in the real world is actually based and like this. So as you can see now, we have this nice multi-lobe specular highlights, and yeah, that's how we create it. And we still can go ahead and add more layers like we did with the standard shader. For example, we can go ahead and add another layer which be between 0.3 and 0.05 here, and for example we can add a standard shader that has a roughness of 0.15, and then add that as a second layer and use the sharper standard shader as the third layer, and that we would actually add more level of realism. But at the same time we would have when you add these layers, you're going to increase your render time. For example, this render was about, let me just show you, about 2 minutes and 26 seconds, and this one is about 3 minutes and 43 seconds. So it's going to get increased as you increase the layers and add more layers, but you get more realism at the same time. The way I combined these basically specular layers, and especially using this curve to control the specular reflections and the way to control the blending between these two standard shader is based on a technique that taught by Grant Warwick at masteringcgi.com. He has a Vero for 3ds Max course that talks about these principles. So all the credits for this technique goes to him, but as you can see, the final results are definitely worth. So that's about this, guys, and in the next lesson we go and implement these techniques and add a few more techniques to go ahead and create more realistic material. But for a toy, I think this is a believable, realistic material. I hope you enjoyed this lesson, and I see you in the next lesson.